In this screencast, we're just going to look at some of the basic ways to do data visualization, just some of the basic visuals that help us summarize a data set. So let's begin. In statistics, the data we work with either represents a whole population of interest, a large group, or else just a sample from the population. And in either case, we want to describe the individuals by variables of interest, which are either categorical or quantitative. And instead of definitions, let's look at an example. Suppose we're interested in studying the population of all Edgewood College students. Some of the variables, the things that change from student to student, might include academic major. That's a categorical variable because major is a category, it's just a label. Math, physics, art, business, psychology. Or GPA is another variable of interest, and that's quantitative. That's a number. It makes sense to ask what's the average, what's the highest. Gender, whether the student is a man or a woman, that's another category. The number of hours per week of paid employment they have, that's a quantitative variable. It's a number again. Number of credits in progress, also another number. And it might be difficult to get all this information for all 2,500 students, so perhaps we look at a sample. And again, another reminder, the word population does not need to refer to people, rather it's the large group of interest. In descriptive statistics, the main goal is to describe a population or a sample in order to understand it, to see patterns, to be able to summarize it. And to do this, we use data visualization, graphs, charts, other visual summaries. We also use numerical summaries, which will be the subject of our next screencast. So visualizations of data can be quite complex. So this is a kind of data visualization that's called a heat map, even though it's not seeing heat in this example. So this shows how salty the world's oceans are over the whole planet. And the colors tell you quickly which areas are most salty and which areas are least salty. So data visualizations can be very, very interesting, very, very complex. We're only going to be looking at some simple ones. The data we'll use for this is all the homes that were for sale in Dane County at one point in time. And you'll find this in the data bank section of our Blackboard site in an Excel file. And we're going to use this one data set to introduce all of our major kinds of graphics. And for categorical variables, they're very simple ones, pie charts and column graphs. So this is a pie chart which shows the distribution of houses that were for sale by the number of bedrooms they have. And I'm sure you've been seeing pie charts since 3rd grade, if not before, but it's a useful one, so there's a reason you've seen it before. So this quick visual tells us, 59% of the homes in our sample had 3 bedrooms. So down here, 59%. 26% had 4 bedrooms. It's kind of dark, but 5% had 5 bedrooms. 1% had 1 bedroom, and so on. It shows us how a whole is divided into proportions. It's very simple, but useful, and it tells a quick important story about what the houses in Madison look like. In my PowerPoints, I sometimes show slides like this one that shows how to do things in Excel. Just for reference, if you download the PowerPoint later, I'm not going to talk about it during the screencasts. Okay, next is column graph, and that's when absolute but not relative numbers are wanted, and we're not looking at parts of a unified whole. We're not dividing up one pie. So we're moving to Dane County, and we want to buy a house near Madison, but we don't want to live in Madison, so we look at some of the communities around Madison and just ask how many houses are for sale in each of those. Let's just do a quick comparison. And again, the data is categorical. A house for sale is either in Sun Prairie or it's in Fitchburg. Those are categories, not numbers. But with this simple column graph, we can see, McFarland, 54 homes for sale, but Sun Prairie had 220 or whatever, estimating. Now, for quantitative variables, the story gets a little more interesting and a little more complicated. This is called a histogram, and it can be complicated, so let's just look at it a little bit. This is the distribution of the home prices, of the asking price for the houses that were for sale in Madison. Down here on the x-axis we have price, 0, 200,000, 600,000, so this will be 400,000. And we see in this first section from 0 to 200,000 we've got 2 columns, so each one represents $100,000. So this first tiny one tells us how many houses there were for sale between $0 and $100,000. And on the y-axis, that tells us how many houses there were. So between 0 and 100,000, I don't know, maybe it was 20 houses. Between 100,000 and 200,000, almost 500 homes for sale. Between 200,000 and 300,000, down here on the x-axis, there were a little under 400 homes for sale. And we see this long tail. Up here around $1 million, there were few homes, very few homes for sale, but there were some. This shape, by the way, is called right skewed. It's got this long tail going to the right. So this simple picture lets us see, oh, okay, almost all the houses cost between 100,000 and 300,000. There's a significant number between 3 and 400,000, and then smaller numbers of houses as we go up. And only a very few houses cost less than 100,000. So this is what's called a histogram, and it's just great for showing how one quantitative variable is distributed, what all the values are and how many there are. To make histograms in Excel, don't do it. We'll use a website called Plotly to make histograms, and we'll see how to do that either in screencasts or in class. Okay, box plots, which we also make in Plotly. So box plots can be kind of complicated to understand too. It's hard to see what this picture is showing, but let me try to explain it. So here in this box plot, we have this deep dark line right here in the middle, and it's at a price. So over here we have prices at a price of about, oh, I don't know, $200,000. Just estimating where this black line hits the y-axis. So here along this y-axis are the price in hundreds of thousands of dollars. And what this is telling us, this black line is the 50 percentile, it's called the median, we'll see later. It's telling us that half the houses cost less than this $200,000. 200 and something, maybe $1,000. So half the houses cost less than this $200,000. Now how about this bottom of the box down here? That's called the first quartile. And if we followed over, that's just a little below $200,000. I don't know, maybe it's 180. It's telling us that 25% of the homes cost below 180. This line at the top here, which comes in at, I don't know, 200, maybe $300,000 almost, tells us that 75% of the houses cost less than $300,000. So the bottom line is the 25% mark, the thick line is the 50% mark, the top line is the 75% mark. Down here, this one represents the very cheapest house. It's hard to say where it is, under $100,000 for sure. So this one represents the cheapest house. This line does not represent the most expensive house, actually. We'll talk in class about sort of what this line does represent, but these are also individual houses, and they're called outliers. So basically, well, the quick story is that this line, the placement of this line, to find the placement of this line, take the distance between here and here, between the the first quartile, the 25 percentile, and up here the 75 percentile, multiply that by 1.5, and that's where you put this. And don't stress too much over sort of what I just said or what that means. Basically, you can think of this line as being at the most expensive house except for a small number of outliers. And this one really is at the cheapest house because there's no outliers underneath it. So it's another way of representing one quantitative variable. You see again that most of the houses are in this range. Well, not most, but 50% of the houses are between 180 and, oh, I don't know, 300 or something like that. And box plots are particularly useful for comparing the distribution of a quantitative variable in, well, multiple distributions of the same quantitative variable, as in here. It would be hard to do this with histograms, but here we get to easily compare Madison, Fitchburg, and Verona. And we can see that Fitchburg and Verona, the houses are distributed pretty close to the same way, and they're significantly more expensive than the houses in Madison. So box plots are great for comparing one quantitative variable across 3 different categories, like more than one category side by side like this. Okay. Okay, so that's box plots, which we'll also create using our website. And our final visualization that we'll use in this course very much is a scatter plot, and it shows how two quantitative variables are related to each other. And we saw one like this in our first introductory lecture. Each of these dots represents a house, and what this is, the story this is telling us is not a surprising story, that bigger houses cost more. And not only that, but in a kind of predictable way. There's some crazy variation up in here, but more or less the sort of predictable way in which the bigger the house explains the higher the cost. And we'll be exploring that a lot later in the course, and actually next week, I guess, in linear regression. But that's the story for another day. Okay, so we've seen 5 common graphs for displaying data visually. Pie charts and column graphs are good for categorical data, histograms and box plots for quantitative data, and scatter plots for the relationship between two quantitative variables. In the next screencast, we'll see how to summarize data numerically with a small number of numerical summaries.